Hi, hello. Hello everyone. Welcome to this video. Today we are going to learn a lexical analyzer in compiler reasons. The name sounds difficult, right? But the idea is very simple. Okay. So lexical analyzers read your programs and break it into small meaningful part. Okay. These part are called tokens, right? So we know, right? So where is lexical analysis? So lexical analysis is the first phase of compiler. Whenever we give a source code as an input to lexical analyzers generate the tokens. Okay. Okay. So for example, look at these codes. Int total equal as plus 25, right? Here. Int is a keyword, total is a identifiers names, and equals and plus or symbols or operators, and 25 is a number, right? So in this video we will learn tokens, patterns, lexemes, and lexical analyzers with easy examples. Okay, let us start. Okay, first let us see where lexical analyzers comes in. Okay, so it is the first main phase of compiler, right? So the programmer gives the source code, lexical analyzers read the source code from left to right. Okay, it group the characters and create tokens, then it send those tokens to the parser, right? So it also skips some extra spaces, tabs, new lines, and commands. It finds the invalid symbols also, or something if it is incomplete words, it reports on errors. So lexical analyzer is the reading and cleaning steps of the compiler. So here is a simple definitions. So lexical analyzer is a scanner. First of all, lexical analyzers we call it a scanner. It changed the characters into tokens. Look at the line, int count equal to 10 followed by semicolons. Actually, the analyzer read int as a keywords. It reads count as an identifier. It reads equal symbol is the assignment operators. Okay, it's read 10 is a number and semicolon is a separated. After these, the parser receive tokens instance of individual characters. So remember, characters goes to and tokens come out. Okay, characters goes in and tokens come out. So the three important there are let us understand the three important terms: tokens, pattern, and lexeme. Token means categorize, pattern means rules, lexeme means actual words or symbols written in the program. Okay. Look at the examples. Sum equals price plus 10. Okay, here someone price or the actual lexemes. Okay, that tokens type is integers. The token type is integer. The rules used to identify them is called a pattern. Okay, how in what way we are going to identify it is a way identifier, right? So that is called a pattern. And I'm telling that one of the easiest way to remember this. So token is the name. Token is the name. Pattern is the rule. Token is the name, pattern is the rule, and lexeme is the actual text. Okay, so name, rule, actual text. So this will help you to easily remember what is pattern, what is rule, and what is lexeme. Okay, so let us see the common type of tokens. Okay, so keywords. So we know keywords are reserved word in all the programming language, right? So keywords reserve words like int, if, while, that will be considered as tokens. Identifiers. So we know the rules for identifier, right? So whenever we create the identifiers, like whenever nothing but like variable names or function names or class name, something like that. So Identifiers, how we can create identifier? There is certain rule in each every programming language. Suppose we're taking C programming language, how can you create identifier? Identifiers to start with the letter and followed by letters or characters, like digits or character, right? So, so identifier here are names given by the programmers like sum or count. Okay, so number can be a 10 or 3.14. Operators include plus, minus, equals, and double equals everything. String is a text written inside double quotes like hello. Okay. So lexical analyzers identify all these tokens and send them to parser. Okay. A pattern actually here. What is pattern? Pattern is a simple rule. It tells us how a token should look. Okay, so let us how a token should look. For example, an identifier normally starts with a letter. After that, it may contains letters or digits. So totals and count one and student twos are valid identifiers. And integers, the rule is one or more digits. For example, 10, 25, and 250s. Okay. So these patterns are often written using regular expressions. So for now, just remember the patterns help analyzers find the correct token types. Okay. So let us see what is the Lexeme. So Lexeme is the exact text found in the programs. So in this line, float average float is Lexeme, average is other Lexeme, equal sign equal symbols is also Lexeme, total the slash symbols, count, and semicolons are also Lexemes. Okay. So each Lexeme has a token type. For example, the average, total, count are the different words, but all of them are identifier. So token is categorized and Lexeme is an actual text. Okay. Like so these tables give us a quick comparisons, right? Like for identifiers, the pattern is letters followed by letters or digits. For example, x, totals, and counters, everything. For a number, the pattern is one or more digits. Examples 10, 500, 20, 26. Okay. So the keywords include if, else, return, void, something like that. Operators include plus, minus, equals, double equal, divisions, multiplications, everything will come under the operators. So remember, pattern is rules, lexeme is the matched text, and token is the characterized name. Okay. Okay. Let us see how scanning works. The analyzer starts from the first characters and move from left to right. So in other word, positions. Okay, it's read all the letters together, then it check the patterns and identifier, positioning as an identifier. It create tokens and move to the next part of courses. Usually, the analysis takes the longest possible matches. For example, a double equal should be taken as one operator, not as two separate symbols. Okay. Things. Now, so not every character is becoming tokens, right? uh, like extra spaces, tab, new lines are normally ignored by the compiler. Why? Because this is only purpose for program to understand what they are writing the course, right? So what compiler will do? Compiler will ignore or skip this kind of extra spaces, tabs, or new lines in your courses. And also, the compilers ignore the command lines also, like maybe a single line commands or multi-line commands. So these and all the compiler will get ignored. Okay, but analyzers still remember the line numbers. Okay, so these help the compiler shows their usual messages such as error at the line number 5, so something like that, right? So space commands are skipped, but line information still maintained by the lexical analyzers. And when the analyzers find an identifier, it may store the informations in symbol tables, right? So we know that, right? We have two phases other than these regular phase of compiler, symbol tables and error recovery. In symbol tables, like symbol tables here act like is a small record books. used by the compilers. For example, it can store the name, model, and its types. So later compiler phases use these informations. They can check whether the variables was declared correctly or not. They can also use in during the code comparison phases. Everything. Okay? So analyzers make send the identifiers tokens along with the reference to a single table entries. Okay. Now let us discuss lexical errors. So lexical errors happen when analyzers cannot match the inputs with any valid patterns. For example, an unexpected symbol may be invalid, right? So a string that starts with the double quotes but does not close it called unclosed strings. So yeah, badly written numbers can also cause an error. So compilers should show the line numbers and wrong characters or words. So this help the programmers find and correct the mistakes easily. And the next one, so what happens after lexical errors? Okay, the compiler can try to continue scanning. It may delete the invalid characters, it may insert the missing characters, it may replace wrong characters, okay, or it may skip some inputs until it reach the save points such as semicolons. Okay, so compiler must so shows the clear error messages. The purpose of recovery is to continue and find more errors in the same compilations. And now let us convert these full line into tokens. Okay? Here, the first step, if is a keyword, right? Left bracket is a separator. Okay, okay. So age is an identifier. Very good. And then greater than or equal is a relational operators. 18 is a number. Then we have a right brackets. Okay. So eligible is another identifiers. Equals symbol is as assignments operators. Okay, so true is a boolean values and semicolons and the statements. So now the parsers can use these tokens to check the grammar of the if statement. Okay. So why lexical analysis is important? So without it, parser would have a read every characters itself. They would make parsers more complicated. So lexical analysis give a clear token to the parser. It removes our spaces and comments. It group characters correctly. It also finds simple error at early stages. So this make the compiler easier to design and fast to work. So lexical analyzer is the cleaning and organizing steps before parsing. Okay. And let us quickly revisit what we learn in these videos. Okay, so the lexical analyzers read the source codes and produce token. So this is clear, right? So lexical analyzer first piece of compiler. So when I am giving the source code as a input to lexical analyzers read the program from left to right and it's produce a token. The token will be given to the next piece of compiler called parser. Okay, and then the tokens. Token is categorized such as like it can be classified in different type of tokens. Like it can be a keyword, it can be identifier, it can be number, or it can be operator, whatever it is. Okay. So our next one, patterns. So patterns is a rule used to identify a tokens. So we know what is token, we know what is pattern, and we know what is Lexeme. So Lexeme is nothing but actual words or symbols found in the programs. Okay, so lexical errors happens when the input does not matches any valid token patterns. Okay, for practice, take a small C or Java programs and identify tokens. Okay, so thank you for watching. We will see you on another video, guys. Thank you, guys.